Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this problem using the concepts of subtracting functions. As per the problem, use the given graphs for f at x and g at x and superposition principle to graph g at x minus f at x. Write the domain and range of g at x minus f at x. We are given these two graphs. Let's start with Part A. In Part A, the red line represents function f at x, the blue line represents function g at x. As per the superposition principle, the difference of two functions can be found by subtracting their y-coordinates for all points along the x-axis. This is a very important concept we need to understand and memorize to solve this type of problem. So we should prepare a table of values for functions f at x, g at x and g at x minus f at x. We should use 5x values from the given graph. We can use -2, -1, 0, 1 and 2. At x equals -2, f at x is equal to -1, this point on the red line. At x equals -2, g at x is equal to -1, the same point on the blue line. So at x equals -2, g at x minus f at x is equal to -1 minus -1, which is equal to 0. Because -1 minus -1 is equivalent to -1 plus 1, which is equal to 0. The next x value is -1. At x equals -1, f at x is equal to 0, this point on the red line. At x equals -1, g at x is equal to -2, this point on the blue line. So at x equals -1, g at x minus f at x is equal to -2 minus 0, which is equal to -2. The next x value is 0. At x equals 0, f at x is equal to +1, this point on the red line. At x equals 0, g at x is equal to -3, this point on the blue line or the y-intercept. So at x equals 0, g at x minus f at x is equal to -3 minus 1, which is equal to -4. At x equals 1, f at x is equal to 2, this point on the red line. At x equals 1, g at x is equal to -4, this point on the blue line. So at x equals 1, g at x minus f at x is equal to -4 minus 2, which is equal to -6. At x equals 2, f at x is equal to 3, this point on the red line. At x equals to, g at x is equal to -5, this point on the blue line. So at x equals 2, g at x minus f at x is equal to -5 minus 3, which is equal to -8. Now we can plot these points for g at x minus f at x to get the graph of g at x minus f at x. The first point is -2, 0. The next point is -1, -2. The next point is 0, -4. The next point is 1, -6, and the last point is 2, -8. These points can be joined by a straight line. So this is the graph of g at x minus f at x. Now we can write the domain and range for g at x minus f at x. The graph of g at x minus f at x is a straight line that extends indefinitely on both sides. There is no restriction on the domain, so the domain is just xer. In interval notation, the domain is -infinity to +infinity. Now we can write the range. Range is set of all possible y values for a function. Since the graph is a straight line that extends indefinitely in the upward and downward direction, there is no restriction on the range, so the range is yer. In interval notation, the range is -infinity to +infinity. We are done with part A. Now we can analyze part B. In part B, function fx is represented by the red line. Function g at x is made up of two straight lines that meet at the y-axis at y equals 7. In order to use the superposition principle to graph g at x minus f at x, we should prepare a table of values. The graph of g at x is made up of two straight lines that meet at x equals 0. So we can use couple of x values on the left side of 0 and couple of x values on the right side of 0. So we can use the x values -2, -1, 0, 1 and 2. At x equals -2, f at x is equal to -4, this point on the red line. At x equals -2, g at x is equal to 5, this point on the blue line. So at x equals -2, g at x minus f at x is equal to 5 minus -4, which is equal to +9. At x equals -1, f at x is equal to -2. At x equals -1, g at x is equal to 6, this point on the blue line. So at x equals -1, g at x minus f at x is equal to 6 minus -2, which is equal to +8. At x equals 0, f at x is equal to 0, this point on the red line. At x equals 0, g at x is equal to 7, this point on the blue line. So at x equals 0, g at x minus f at x is equal to 7 minus 0, which is equal to 7. At x equals 1, f at x is equal to 2, this point on the red line. At x equals 1, g at x is equal to 6, this point on the blue line. So at x equals 1, g at x minus f at x is equal to 6 minus 2, which is equal to 4. At x equals 2, f at x is equal to 4, this point on the red line. At x equals 2, g at x is equal to 5, this point on the blue line. So at x equals 2, g at x minus f at x is equal to 5 minus 4, which is equal to 1. Now we have the points for g at x minus f at x. We can plot these points. At x equals negative 2, g at x minus f at x is equal to 9, somewhere here. At x equals negative 1, g at x minus f at x is equal to 8, here. At x equals 0, g at x minus f at x is equal to 7, and that's here. At x equals 1, g at x minus f at x is equal to 4, so that's here. At x equals 2, g at x minus f at x is equal to 1, so that's here. On the left side of the y-axis, the points can be joined by a straight line like this. On the right side of the y-axis, the points can be joined by a straight line like this. So this is the graph of g at x minus f at x. Now we can write the domain and range for g at x minus f at x. Domain is set of all possible x values for a function. The graph of g at x minus f at x extends indefinitely on both sides along the x-axis. There is no restriction on the domain, so the domain is just xer. In interval notation, we can write the domain as negative infinity to positive infinity. Now we can write the range. Range is set of all possible y values for a function. The graph of g at x minus f at x extends on both sides along the y-axis. There is no restriction on the range, so the range is yer. In interval notation, the range is negative infinity to positive infinity. So we are done with part B. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.